Hey everyone, this is Aman Soni and welcome to M12. The previous classes we have seen the forward and the backward propagation, and we have also seen like what kind of different activation function should be ideally used in different kind of scenarios. Okay, so in this class we are going to be seeing the practical approach towards the artificial neural network, and we are going to be using the Jupyter notebook in order to run our Python commands. Okay, so I am very excited and let's get started. Let me directly jump on the Jupyter notebook. Okay, so here it is. Let me first import pandas as PD. Okay, and now let us import our dataset. df is equals to pd dot read csv, and here goes your file path. Okay, so let me first show you how our dataset looks. So this is our diabetes dataset, and all of these column here are our independent variables, right? And this here outcome feature, that is our dependent variable, right? So one means the person is suffering from the diabetes, and the zero means the person is totally fit. Okay, so let me first import it. Okay, so let me write the path here, right? And then after that, let me show you how our data frame looks like. Okay, so this is our data frame and these are our features, right? And this is our outcome value. And after that, let me first see what are the different data types of our different kind of features. df dot d types. Okay, so all of the values here lies in integer or either float, right? So which is good. Like if we had the data values as an object or string, we would have to convert it into the integer portion, right? Okay, so let us first analyze our data set, right? We have pregnancy, we have glucose, blood pressure, and so on, right? So don't you think like pregnancies are in the range of 0 to 10, right? Then after that, the glucose lies in the range of 148. We have 183 as well. Don't you think uh, in glucose feature, like when we'll be passing this data set for the training of the neural network, the glucose will be having the higher weightage than the pregnancies, but ideally it shouldn't happen, right? The weightage that is provided to the pregnancies, the similar weightage should be provided to the glucose as well, right? But in this case, the value of the glucose, the range of the values of the glucose is far more than the pregnancies, right? So it will be having the higher weightage. So in order to deal with that, there comes the concept of scaling, right? What is scaling? I have already covered the scaling part in the previous video as well. I'll give you the link in the upper right corner as well. Okay, so in scaling, we'll scale the values of the pregnancies, glucose, blood pressure, and all the features here in the range of like 0 to 1, or like there are two different kind of scaling techniques. In first, like you can scale the value from 0 to 1, that is normalization, and the second one, like in the standardization, what we do, we standardize our whole data set, like its value can be negative or either positive, but the mean of the value will be 0, right? So this is our feature scaling method. Okay, so before standardizing our dataset, let me first split our dataset into two types. The first are the features; those are the dependent features, and then after that, the independent features, right? So X for independent features, and we have to select only those features; those are independent of the final outcome, right? So all these features are our independent features. So for selecting that, let me introduce a drop feature, df.drop. Then after that comes the name of the variable which you want to drop. Here comes the outcome. After that comes the axis. Axis equals to 1, right? let me show you how our dataset, how our X value looks like. Okay. So now you can see here, like the outcome feature is missing, right? Similarly, we have to select the Y as the outcome. Df dot outcome. Let me write, right? So yeah, our dependent feature, sorry, yeah, our dependent feature is Y and our independent feature is X. So now let me import a library sklearn in order to use the standard scalar, or you can say in order to standardize our dataset. So yeah, scalar is equals to, before using the scalar, let me import that from sklearn dot preprocessing import standard scalar. Yeah. Since we have imported the standard scalar from sklearn, let me create an object for that. Scalar is equals to standard scale. Right. Now let us fit the value of x in that. X is equals to scalar dot fit transform. Let me pass the value of x here. Right. So this is how our x looks like now. Right. So you can see here the values are already being scaled. Right. In the first, like you can see in the first column as well, the first value of the first column is 6, right? It was all integer, right? But here you can see all the values lies in the float portion, right? So the features are already scaled. So since our data frame is scaled, let me import the train test split, right? We have to split our data into training and the testing portion, right? So for that, from sklearn, sorry, sklearn dot model selection code, yeah, train test split. Start importing train test split, right? We have run that as well. Then after that, let me split our data into training and the testing portion. X test, sorry, X train, then comes the X test. Then after that comes the Y train, then comes the Y test, right? After that, train test split, and let us pass the values here. Like the first value is the X, and the second value is Y. Then after that, there are there are more arguments here, but let me introduce you to two more arguments. The first one here is random state, right? We have covered the random state in the previous portion as well, and again I'll give you the link in the I button. Okay. Then after that comes the uh, test size. What does that mean? That means in what portion or in what percentage do you want to train, do you want to split your data set into the training and the testing part, right? So here I am taking the 25% as my test size. Okay, so let me run that. Let us see uh, our X train values and X test values. X train looks like this, and our Y test looks like this, right? Okay. So till now we have imported the data set, we have done the feature scaling, we have done the data pre-processing step, and we have also splitted our data set into two different parts. The first one was for the training purpose, and the second one was for the testing purpose, right? So now let me import the TensorFlow and Keras in order to build a model, right? So sorry, import TensorFlow as TF, and from TensorFlow import, keras. Let me run that. We cannot import name keras from the TensorFlow. Okay, what is the problem here? Sorry, spelling keras. Yeah. So yeah, it is being imported. If you will be facing some kind of issues in importing TensorFlow and the keras, go to the documentation and first install the TensorFlow and the keras into your computer. There's a command called the pip install TensorFlow, and it will definitely run fine. Okay, so let's move further. So let me now introduce a sequential model here. Model is equals to just sequential. Okay, so what does sequential do? Sequential does nothing, just uh, it runs all your neural network layer in a sequence, right? In which we are passing them, nothing else, right? Then after that, keras dot sequential. Then we'll be passing some layers, right? So keras dot layers dot dense, right? So what is dense? Dense is nothing but a layer only, right? Layer of neurons only, right? So now we have to pass like how many neurons do you want in your first layer, right? So we are writing dense for the first time. That means it is our first layer, right? And we have to specify how many number of neurons do you want in that, right? So let us first see the data set. So this is our data set, right? We have 8 features and we have 768 rows, right? So don't you think, like, if we'll give 8 neurons only, each feature will go to a specific neuron and then after that it will converge on the next neuron, right? So ideally, like, there is no such thing as ideally, but still, how many number of features you are having is good to know how many number of neurons do you want in your first layer, right? In this case, we are having 768 rows only, so we'll be giving the first layer only 8 neurons, right? 8 here. And now we have to select the activation function for that. Like in the previous classes, in the last video only, we have seen how to select the activation function, right? So I won't be discussing it here now, but I'll give you the link in the description box. Okay, so you can always check it out. So after that, let me give the activation function. Activation is equals to value. Okay, then after that we have to pass the dimension of the data. Input dimension is equals to 8 plus 0. Okay, so that means we are passing the 8 features into it. After that, let me add one more layer here, right? Keras dot layers dot dense, and we have seen our data set is not that wide, right? So it is okay if we use 2 layers only, right? So here I'll only use one, and then after that pass the activation function here. Activation is equals to, like, it is a binary classification model, so I'll be using the sigmoid only, right? So sigmoid activation function, right? Here we don't have to pass the input dimension because it automatically receives the dimensions from the first layer. So let me run the model. Okay, so it is giving an error, that is index method got value. Okay, we have passed this wrongly, right? Then after that, let us compile our model, right? Model dot compile, right? Uh, what optimizer do you want to use? Generally, I prefer the Atom optimizer in case of binary classification, right? So optimizer is equals to item, right? Then after that comes the loss value. Loss is equals to binary cross entropy. In case of binary classification model, we generally use the binary cross entropy as a loss function. Okay. Then after that, let us decide the matrix, the evaluation matrix. ICS is equals to accuracy. We'll be getting the accuracy matrix. Okay. Model is compiled. Then after that, let us fit the data into our model. Right? We have made a model. We have also compiled it. Now it's time to feed it some data in order to let it learn. Right? So model dot fit, like we have two terms here. The first one is the fit and the second one is the fit transform. Like if you are using the fit, that means your the data frame, or you can say the data set is scaled, right? If you are using the fit transform, that means you haven't scaled your data yet, right? So we have already done the feature scaling above, so we'll be using the fit only, right? So model dot fit. Then after that comes the the values on which the model should be trained, right? So x train and y train, right? Now how many epochs do you want it to run? Let us first take epochs to be 10. Epochs is equals to 10, and let us run it. Type error, fit got an unexpected keyword argument, spelling mistake, oops. Yep. Now the epochs are running. The first epoch, that means the accuracy is 55, 58. Now you can see here, like the values are, the value of accuracy is still improving, and we have provided some less epochs, right? So let me increment the epochs here. Let us take 50 here. The accuracy is increasing, it is going 77. Then after that, you can see here, uh, the accuracy is stagnant. Like it is giving you the 77, then 76, then it is only giving you the 76.91 value, right? So after 30 epochs, it is stagnant, right? So why do we waste our memory for 50 epochs? Let us only run it for the 30 only, right? So for the 30 epochs, it is giving the accuracy of 0.77, that is 77%. Okay, so congratulations, you have already trained your first model, first deep learning model, right? Now let us evaluate uh, what the model is predicting to us, right? So let us evaluate it first. Model dot evaluate. Then after that, let us pass the test values. X test, sorry, X test. Then comes the Y test, right? It is showing us the value of accuracy as 0.79. That means our accuracy score here is approx 80%. So now let us test our data on the testing data, right? So for that, y predicted is equals to, yeah, y predicted is equals to model dot predict. Then after that, let me pass the x test values. X test here. Okay. Let me print the y predicted. Yeah, so it is showing us an array, right? So let me first see the first five values for that. We'll be using the slicing here, and yeah. So the first, sorry, yeah, the first five values here are like this, right? So now you will be wondering, like in the last layer, we have used the sigmoid activation function, right? So it will definitely give us the values that will lie in the range of 0 to 1, right? So now we have to define a threshold, like that is the point. Above that, all the values are 1, and below that, all the values are 0, right? So for that, let me create a for loop, right? So let me create an array for that, and after that, for I in y predicted, if I is more than zero point 0.5, right? That means array dot append 1. Otherwise, array dot append 0. Yeah. So now let us see how our array looks like. Okay. So array dot 5. Yeah. So this is our values. Okay. So that means the first customer was having uh, the diabetes, the second one was not having diabetes, and so on, right? So let me first show you how our testing data looks like. What was the y test values? Y test 0.5. Okay, so like here as well, the first person was having diabetes, the second one was not having diabetes, and the last second person was having the diabetes. And similarly, the things that our model predicted was somehow correct, right? Like in this data set, it is all correct, but according to our accuracy score, the 80% values will be correct, right? So let us now see the F score, and let us see the accuracy, let us see the precision of our model. Let us create the classification report. Okay, so for that, from sklearn dot matrices info classification. Yeah, so print classification report. So then let us pass two values. First one is the array, and the second one was by test. Right. Let's print that. Classification report is not defined. Yeah, still it is not defined. We copy it only. There will be some silly uh, spelling mistakes. Yeah. From the report we have got from our model, the precision for the class 0 was 0.89. That is like very good. Like it is 90% approx, right? But for the class 2, it drops down to the 60%, right? The accuracy is 80%. The F1 score for the class A was 86, and for the class B was 0.65. Okay. So this was all about our model. And let me also tell you why this happened. Like the precision for the class 1 was very good. The class 2, it dropped down to like 60%. Why did that happen? Let me first show you the values of 0 and 1 in our data. Okay, so the df was our data, and df dot outcome dot value counts. So here it is. Like for the class A, we have 50 data points, right? But for the class B, we have almost half the data points which we were having for the class A, right? So that was an issue, right? So how are we supposed to get the good accuracy for class B as well, right? So to tackle that, there are various techniques used to handle the imbalanced data set, right? So to make it balanced, there are different techniques, right? So we'll be covering those techniques in our later videos. If you have gained some knowledge from this video, please hit the like button and do subscribe me. That will boost up my confidence as well. Okay, so this was all about the today's lecture. See you in the next video. Bye bye.